Good afternoon in these sessions. So today in these sessions, we will discuss about the Cosmos DB. So it is basically the introductory sessions about the Cosmos DB, what are the benefits or why we are using Cosmos DB in case of any non-SQL database. So let's begin the sessions. So I'm Debasis. I'm a Microsoft certified trainer and CSAP Corner MVP. Also, I'm a Azure and full stack specialist and working as a lead engineer at We5 Soft Pune. So in today's sessions, we are discussing about the following topics like concept of NoSQL databases, overview of concept Cosmos DB, how to create a Cosmos DB database using Azure Portal, how we can managing throughputs in a Cosmos DB database, what is a document model concept in Cosmos DB, how we can perform data query or fetching some data or select query type query in SQL using Cosmos DB with the help of SQL API databases. And also we'll discuss a little bit about the server-side programming in Cosmos DB, how we can perform different server-side objects like source positive trigger, UDF, etc. in our Cosmos DB platform. And at the end, we will have a Q&A sessions. So at first, we will discuss what is actually NoSQL database. So normally we have a basic idea about a database concept. So database is basically used for store some data in a structured way. So normally those databases are known as the SQL-based database or structured database. But in case of NoSQL, NoSQL basically stands for not only SQLs. That means in case of NoSQL database, it does not need to store the data always as a structured way. So in most of the cases, NoSQL databases does not support any RDBMS concept features like primary key, foreign key, etc. In a single word, these databases are much more independent of schema or database architecture. Like so, in normally we can categorize NoSQL database in different types, but mostly we can categorize any NoSQL database into 4 different types. So the first one is the document database. In document database, we can store any type of document or data in a NoSQL data format structure. So the example, most popular or best example in document database case is Azure Cosmos DB and also is the MongoDB. These are the two most popular and widely used databases of NoSQL category as a document database. The next one category is key value database. In this case, we are storing data as a key value pair in a database. So as a key value pair, we need to mention the key and against value against a particular key and store in the database. So some examples of the key value pair database is Redis is the one of the best example of key value pair database and also the React. Another is the column store database. Column store database is basically stored data in a column structure way. Cassandra and Bigtable is one of the two examples of the column store database. And the last one is the graph database. Nowadays, this graph database mostly used in different platforms like social networking sites or any applications where different types of relationship is required between the data. We'll discuss a little bit about a graph database in the next portion. So the example of the graph database is GraphDB and a Neo4j. So first we will discuss about the key value database, key value pair database. So key value pair database is basically represents an array of values which always have a defined key. That means in case of this types of database, we always store a value against a specified or predefined key name. So in this case, if we want to retrieve the data from the database, then we need to use that key name to retrieve the data. And key name must be unique across all document. That means if one record is inserted against a particular key name, in that case, that same key name cannot be used for another data or another sets of records. If we use the same key name for another sets of record, in that case, whenever we find the data, we'll fetch both the records. So this is some example of the key value pair database. Like here in this example, K1, K2, K3, K4 is the key name, and against the key, we can store different types of data like a numeric value or a character or string type value or a combination of both alphanumeric like a character and combinations, or we can store a object or JSON structured data like the K4 key. So these different types of value can be stored in a single database structure because this NoSQL database basic criteria is that there have no predefined schema or data type. So we can store any type of data or any structured data in NoSQL database. So that is one of the main advantage of any NoSQL database. So next one is the document database. Actually, in our most of the applications, we are mainly used as the NoSQL database as a document database in most of the cases. So document database is basically a schema-less database. In this database, we have a similar concept, quite similar concept of RDBMS concept, like table, rows, columns, etc. But the one thing is main different is that here we does not have any schema, table schema name. So each and every object or container is basically is a schema independent. Each document might store different types of data because in one of the another advantage of NoSQL database is that in NoSQL database we can store any type of data. Like as for example, in case of SQL database, if we define a table called employee, and if that table contains 4 different fields, say employee ID, employee name, employee city, and employee date of join, and now according to that table we creates an applications page or web application page. And after that, if we require to add new columns in that particular table, then definitely it is possible. But in that case, we need to work much because we need to change the database structure. We need to include the new columns and also predefine the default values of those new columns. What would be the default values? And if we want to add any new columns in the particular table, which that column can always require a value. And in that case, if the table contains a few records, then we need to first create that table column as a null column, and then update the value from a backend process, and then only we can mark that column as a required column. So in that way, we have a pretty much database related or backend related work is required for SQL database whenever we increase or change the database structure horizontal. So vertical scaling of a SQL database or SQL structured database is always possible, but horizontal scaling is quite difficult for any RDBMS-based database. But in case of NoSQL database, horizontal scaling is very much easy because for making any horizontal scaling or making any extra columns included or extra property included in NoSQL database, we does not need to work with the database part. We just need to provide the provisions in our application so that user can input those data and then data directly saved in the database. For that purpose, we does not need to change the database structure or any database extra database work. Like this is the sample examples of one object document, that is which contains a customer, order ID, product, price, currency, and discount. Similarly, we can create another object like this, where maybe the customer we have the same property, but rest of the 3 properties are different. So these 2 different documents we can store in a single database or in a single place, and as a 2 different objects or 2 different documents. So in this way, we can use different type of structure, database structure against each and every record or row. Similarly, we can store a nested data in a single row, like the third example. So if we have a customer ID, product ID, review detail, and also we have a review detail, which is basically is also an object. So which contains some other property within the review detail. So we can store entire this structure with parent and child relationship with data in a single document. And also we can store these types of multiple data object-based data in a document model. So these are the 4 different types of document set examples, which types of data can be stored in a document database in NoSQL format. Another next one is the columnar database. Columnar database is basically always stored as a column-based data family. Column means is basically concept of table-based row column concept. So this is the example of columnar-based concept. So in this concept, data records is stored in a particular way, and each and every record represents a columnar ID. Like the customer ID is a column, and against the identity column, we can store multiple fields records like title, first name, last name, for that against that customer ID. So these types of data storage is basically known as a columnar database. So also in this case, also we can maintain different structure for different types of records. And the last one is the graph database. Graph database is now have a much popular nowadays because most of the social networking sites are using the graph type database for their database relations. Because in case of graph database, over here we can establish a relations against each and every data with each and every record. So it's basically is a multidimensional relationship examples. So relationship is much more fluid in this concept and can connect a multiple different types of data. So this image is basically represents a sample data format of a graph database. Here, home is basically is a data which and soccer classes and these are the different types of database or data, and those are the related or connected with the different types of data to each other. So in this way, we can establish a cross-dimensional or cross-relational data by using the graph database. So now. In case of Cosmos DB, Cosmos DB is basically is a document type database or document based database. So whenever we create a Cosmos DB, we can use different types of approach because in Cosmos DB, we can use to store data in a SQL based format, or we can use the MongoDB based concept or JSON format like this. So whenever we want to create a Cosmos DB database or account, we need to provide or select which type of operations we need to perform in that particular Cosmos DB database account. So basically, Cosmos DB provide 5 different types of operations or API. One of the best or common default API is the document, or which is basically quite similar to the SQL-based API. We are normally call this as a SQL API in the Azure Portal. Another is also support the document DB document-based object structure, but in that case, we can use the Mongo-based API, or in that case, so the difference between document SQL API and document Mongo API is that both are the Cosmos DB account, but when we create a Cosmos DB account, we can create an account in such a way that if we require to run SQL type command for our fetching or inserting records or operations, or different types of database related operations, then we need to use the SQL based API. But if we are familiar or quite confident to using the Mongo based commands like Mongo commands which are we are normally used in case of MongoDB, in that case we can choose the Mongo API for Cosmos DB. So Cosmos DB can act as a SQL based API act through using a SQL based API command, and also can act as a Mongo-based API command. At the same time, Cosmos DB have to different another command because the popularity of Cosmos DB, this is not only for the document type database, because Cosmos DB is such an account or database which basically supports all types of NoSQL database. Means we normally prefer to create a document-based database by using a Cosmos DB, but also we can create other different types of database by using a Cosmos DB, like columnar database or key type value pair database or a graph database. So each and every types of database, Cosmos DB account provide different types of API to operate. Like for columnar database, it provides a Cassandra API. For key value pair API, it provides a table API, and for graph, it will provide the Kaplan API. So whenever we create the Cosmos DB account through Azure Portal, we have a list of these 5 different types of API, and we need to select which one we need to create or select. So in case of Cosmos DB, this is the basic hierarchical structure of a Cosmos DB. So whenever we want to create a Cosmos DB database, we first need to open the Azure Portal and need to create our subscriptions in the Azure Portal. And after successful logging or authenticating the Azure Portal, first we need to create a Azure Cosmos DB account. This is the normal first steps of creating a Cosmos DB account in Azure environment. So first we need to create an Azure Cosmos DB account, and then we need to create a database. When we create a database, within the database, we can define collections. Collections basically represents the tables concept of SQL Server or RDBS databases. Within the collections, or we can insert multiple documents or records, which is basically known as a rows in case of RDBS database. And in case of records, we have two different types of options. One is documents, another is attachment. Because in Cosmos DB account, for each and every record, we have a specific size limit. Like whenever we insert in any record against a collections, we can maximum insert any size of data. But if the size is within 2 MB or up to 2 MB, then that particular document is stored as that particular records that are stored as a document in the Cosmos DB collections. But if the document size or record size is above 2 MB, in that case, Cosmos DB internally collect the data and store in the Azure blob storage and put the reference and collect the reference of the documents or that data in the Azure blob storage and create the documents within the collections where it stores the reference of that Azure blob storage. So whenever we want to fetch that record, Azure internally collect the data from the blob storage and return to us. In case of database, like within the database, we can create obviously collections and then insert documents. But also in the database, we can create users for implementing different types of security or permissions level. So against user, we can definitely provide a permission, different types of permissions. And against the collections, we can create three different types of server object. One is stored procedure, another is trigger, and third one is user-defined functions or UDF. This tree object is basically known as a server-side of objects or server-side operations types object. So whenever we're going to create a Cosmos DB account, this is a normal screenshot where we can create a Cosmos DB account in the user. So through this part, we can create a new database or create a new collections, new SQL query means we can perform the new SQL query, or we can write down new store procedure or upload data from a JSON format data structure or a CSV file, etc. Or even we can delete the database or collections. So before going to create a Cosmos DB account, we first want to know about the throughput concept in a Cosmos DB. So whenever a database we are using, the performance is the one of the key factor for selecting the database or finalize the database structure. Suppose if we want to store a billion of records in a database, and if the database returns, if the database is returns as a data, say 1 records or 10 records, 1 minute or 2 minutes, then that is a very bad database response. So we always prefer that whenever we want to fetch records, the response time will be always in instance, need to be instant. So in case of Cosmos DB, the performance of database or response time is basically depends on RU or request unit per second. So this is the basically the measurement of the Cosmos DB performance. So if we need to higher performance, then we need to increase the RU amount volume to high value. Or if you require a moderate or low performance, then we can decrease the RU request. So normally the RU means it use the request per unit per seconds. So how many requests or what are the by size of the request per second is can received by the Cosmos DB. That specifications is known as the RU. So it's to manage the performance and cost of the database. So RU actually basically define the costing of the database also, because Cosmos DB or Azure model is basically follow pay as you use concept. So what are the resources you have used? You need to pay only for those resources. So if your RU high, the request per unit is higher rate, then obviously your costing will be high. So normally in approximate calculations, 1 RU basically means what are if we read a 1 KB data of per second, if we receive 1 KB of data or insert 1 KB of data in a database, and that insertion time or operation time is 1 second, then that amount of data is basically known as a RU, 1 RU. So normally 1 RU means what amount of data database can insert or can return to the user. That amount always needs to be treated as a RU. So in normal concept for any CRUD related operation like insert, delete, RU rate requires it little bit higher, but for fetching or read the data, Array always response rate is always low because for reading the data we require very low RE, but in case of insert or update record in database, we require a higher RE. So document with so this is the one estimate, or say we can say it's a dummy examples that if we have a document with 10 different properties or 10 different columns and that document size is 1 KB and that can be inserted within 1 second, that means this entire document size is equivalent to 1 RE. So basically RU mainly maintains or controls the memory of the memory, CPU, and storage or input-output devices. According to these three parameters, RU performance is either increase or decrease. If we have a if we use a higher density server or higher environment, then obviously in where the memory and CPU or storage IO is higher, then obviously RU require lower. But if we have a lower types of inputs like lower memory or CPU, then we require a higher RU. So in case of migration, suppose also Cosmos DB provide some migration tool so that what the user suppose as a user for existing database user, suppose I am a user and I am using a SQL Server database, and now I want to migrate my entire database data to a Cosmos DB database. So in that case, we have two different choices. Either we need to run a application which is basically internally convert all the data from SQL Server to Cosmos DB, or we can use any third party. So for each and every type of database, Cosmos DB have provide different third party tools to migrate data from other different database sources to Cosmos DB database accounts. So for migration tool is like DTUI or DTEXE is basically used for migrate any data from any SQL based database to Cosmos DB account. Obviously, for that purpose, we need to use the Cosmos DB account with SQL based API. If we want to migrate any graph database data like Gremlin, like into a Cosmos DB account, then we can use GraphSun import or Gremlin console to migrate those data from Gremlin database. If we have have a MongoDB database, and we want to migrate all data of a MongoDB to a Cosmos DB account, then we need to use the Mongo import or Mongo restore commands of Mongo server so that it can communicate with the Cosmos DB account and migrate the data. If we have a table type database and we need to migrate it to the Cosmos DB, then we need to use az copy command or dt.exe. And also for Cassandra or type or document key pair value type database, we can use SQL SH copy or Spark connector to migrate data from Cassandra database to Cosmos. So before going to create a Cosmos DB account, we first need to understand the relations between the documents and the collections. So in this example or this table structure, we demonstrate or we discuss what are the document object structure in NoSQL database in compared to relational database. So in relational database, we know the rows. Rows is basically represents a set of records which contains a set of columns. In case of Cosmos DB or in case of any NoSQL database, rows basically represent as a document. So whenever we talks about document, it basically internally represents a row or records. In case of SQL Server, columns is basically here represent as a properties. So document always contains a number of properties or multiple properties. In case of concept of tables, which is in RDBA systems or relational database, in case of document database, we call this as a collections. So the main relation is one collections can contain a number of documents, and each and every document can contain a number of properties. So this is a hierarchical structure of the document model in Cosmos. And also in relational database, when you store the data, it always stored in the normalized pattern. But in case of Cosmos DB, it always stored as a denormalized pattern or denormalized. Relational database is always a declarative schema. So whenever we want to create a database, in a table in a relational database, we always need to mention a schema. If we does not mention a schema, then that table always belongs to the default DBO schema. But in case of NoSQL database or Cosmos DB database, it is always schemaless. So we can define any types of collections name within a database without mentioning or grouping them as under a schema. In relational database, we have a referential integrity by using the binary and foreign key. But in case of document database, we don't have any referential integrity. So if we want to protect the child data or any sub-relational data, that need to be done by our own applications. Cosmos DB does not help you us to maintain or restrict the release of those data. So interactions between object-oriented programming languages are easier with the document databases. That is why we are normally use document database structure model in case of NoSQL or Cosmos DB. Also, easier querying balance with the need of the maintaining denormalized records. So in this way, whenever we fetch the record, since the record is denormalized, so it does not need to perform any extra joins, or it does not need to perform to establish a link between different tables or different collections within the Cosmos DB or within the NoSQL database, so that we can return the data from a multiple collections, because it can contain the schemaless and any structure of data. So we can store a nested types of data in a single records or in a single document in a Cosmos DB data structure. So in Cosmos DB, normally it stored the data as a JSON format, not as a text format. So whenever what are the data we are normally inserting, those data are stored as a JSON format in a Cosmos DB. So JSON format always called a GeoJSON supported for geometry. If we are wanting to store any geometry related information like lat long, then that particular format can be stored as a GeoJSON format, which is a standard. Each document must have be a 2 MB size or less. So whenever you're trying to insert a document, that document size must be within the 2 MB or up to 2 MB. If the document size is above 2 MB, then that entire document of size above 2 MB will be stored in the blob storage of Azure Portal, and then the release link of or URL or reference point of that blob storage is stored as a document within the Cosmos DB. And these types of reference are known as attachment. So attachment means initially those record is not stored in your documents or collections, but whenever you want to that particular data records by navigating it, it automatically downloaded or appeared in front of you. So the attachment is basically point a URL outside the document. So that URL actually stores the actual record. So within the Cosmos DB document, we only stored the pointed URL where the data is actually stored. Use Cosmos DB blob storage up to 2 GB total per database account or external store. So first one, that is up to 2 GB per database account, is totally free. So we can use our blob storage. If we have already consumed 2 GB and we require more space, then for that extra space, we need to pay the price or amount. System properties always added to all documents. So in case of Cosmos DB, so when we insert some records, there are few system properties which is required to identify that particular record. So those system properties is always inserted against each and every document internally. For those system property, does not need to provide any value. There are actually 4 different system properties: underscore RID, underscore ETAG, underscore TS or time span, and underscore self. Self means is basically identify these records or self records, or you can say that that particular document contains the address of the document or location of URL of the document within the self property. TS is basically for the time span. That means at which time this record is inserted or modified. So it's basically maintain the last edited time. E-tag or electronic tag is basically for any types of electronic tag like internal ID like this. And RID, whenever we want to insert a record, Cosmos will automatically insert an ID field value that is called underscore ID, and store a JSON format or GUI type value within that column. So that is stored in the RID column. So ID is automatically added as GUID if it is not supplied. So if we provide a value in against the ID column like 10 or a numerical number, then that value will be stored. But if we does not provide any value in the ID column and we try to insert a record in the Cosmos DB, in that case, system automatically generated a GUID value and stored in the user ID. So also in case of SQL Server, we can implement the partitioning in Cosmos DB. But in case of Cosmos DB, we have two different types of partitions. One is logical partitions and another is physical partition. So first we discuss about the logical partition. So suppose we have a container. Container is basically is a database. Within the database or say within that collections, we can store different types of documents. Like it's a user document related document and we store 4 different records. And these 4 records is basically identified with 4 different users. Record is related to 4 different users. The first one record is user ID A, second one is user ID B, third one Y, and fourth one Z. So these are the 4 different records. So and if we mention that user ID will be treated as a partition key for different documents within the Cosmos DB account, in that case, this user ID is act as a partition key and we can find the records by using the user ID whenever we want to fetch any record. So this is actually basically known as a logical partition. Also there is a physical partition. Physical partition means suppose I have a Cosmos DB database and I create a Cosmos DB table and then we want our collections and we want to store some records in that particular Cosmos DB. Now we are going to insert 4 records one by one. Now, that it does not mean that these 4 records will be stored in the same place. Maybe this 4 records will store in 2 different places as per the availability or as per the space sequence. So this part is basically known as the physical partition. So what is the rule for selecting a partition key? Because whenever you want to create a Cosmos DB account or Cosmos DB database, we need to provide a partition key against a particular column or collections. A particular table or collections. So for selecting a partition key, collections will be need to be heterogeneous and partition keys should be reflective. Partition keys needs to be a such property which always exists in a record and can be used for that property to distinguish different types of records or documents. Add document type property to documents. Use a generic partition key not registered to part of the domain. We can use that if we have a generic partition key which is not part of the current domain. That also we can use. Also, choice of key is important because which properties is need to be selected as a partition. That is much more important. So first one is the performance. Performance means whenever we want to store any data, we always at the next level we always try to fetch those records from the databases. So if most of the time I need to say fetch a record against user ID or say against a employee table or say I have a 50-50 ratio that user ID can be used for fetching the record or say employee ID can be used. Then accordingly, we need to create a partition key accordingly. But the most preferred theory is if particular identify which property is need to be used maximum times for fetching the records, and that particular property will be your partition key because in that case record will be separated against that particular key, and so whenever we fetching the record, it will provide us a better performance in compared to the other types of partition. Scalability up to 10 GB limit for logical partition. So using a logical partition, we can store a data up to 10 GB. But after that, we need to go to the physical partition. More ethical as collection size grows. So it is much more critical when the collection size grows for a logical partition. So we need to choose the key which probably not be optional for every query. Suppose If against when we try to insert a record, we have a column, say city, and that city is totally optional. As a user, maybe I can provide the city value or may not. In that case, city is not a preferred partition key field, because in case of partition key, it is need to mention or always maintain that that particular field records needs to be inserted all the time whenever we try to insert any document. So now let's open the Azure portal and see how we can create the Cosmos DB account by using the Azure portal. So I'll just open the another tab and open the Azure portal. So whenever if we log in the Azure portal for the first time, then it will ask for the username password. And we have a already account, existing account, and we can directly log in with the Azure portal. And when we log in the Azure portal, it directly loads the landing page of the Azure portal. Here we can create different types of resource. We can create from the Cosmos view from the resource group here, or we can type simply here Azure Cosmos DB. So if we use from here, we have a list of the Cosmos DB of services, and we can select in one of them. Also, in the dashboard, it is normally used the last most 5 or 6 latest used services which we have used. So if there is a Cosmos DB option in this list, then also you can click on this option. So whenever I click on the Cosmos DB account, I am seeing that I have already created one account for demo purpose. If I now want to add another account, so I'll click on the add option, and it will open a Cosmos DB account creation page. So here first you need to provide the subscriptions and then provide a resource group. So I have already created 2 or 3 resource groups, so I can select any one of those resource groups. Or also I can create a new resource group here by typing the resource group name. And then we need to provide the Cosmos DB account name. Say I'll give you Azure 2021. Okay. If the name is not available, it will automatically display you the message like this. That's the criteria. And then we need to select which types of API we need to use in Cosmos DB. So we have a 4-5 options: Core SQL, Azure Cosmos DB for MongoDB API, Cassandra, Azure Table, and Gem. So default is the Core SQL, which is by default selected. But if we want any other types of Cosmos DB account, then we can select that particular types from this list. So I'm using the Core SQL, and then we need to the locations of the server where in which server we want to store this data. So we have different types of server according to billing and payment options. So you need to select any one server from this available list. And then we need to provide provision throughputs. And after that, we have a account type option, that is either this account type is a production type or a non-production type. So if production type, then your billing charge will be higher, because in that case they need to maintain the daily backup, etc. But if it's a non-production type, then in that case there is the billing charges is a little bit lower. Now after clicking on this, we need to click on create and review. And if you are provided all the information is correct, then review validation has been successful, and now you can click on the create button to create the Cosmos DB account. So whenever we click on the create options, it will take some time to deploy the Cosmos DB account in the Azure server. So say this is displayed and development is possible in process. So I'll use my one created Cosmos DB account. So I'm going to the Cosmos DB account. This is previously I created. So I'll click on this. So this is the actual Cosmos DB account info. So in this account part, we can select different types of options like keys. Through the keys, we can contain the Cosmos DB URL, the primary key, or set a password, or the secondary key or password, everything. And if we want to connect this Cosmos DB account with any third-party programming language like C#, ASP.NET, or Angular, etc., then we need to copy this connection string, ready-made connection string, and paste in our connection string part of our applications. Now, in Cosmos DB part, if we click on the overview section, we have a different options that what is the backup policy, that is periodic, means it's a monthly backup. Yeah. So once the deployment is succeeded, it will show you a pop-up that deployment is successful. And if you click on go to resource, then that particular Cosmos DB account is activated. So now if we want to create database, then we need to click on the Data Explorer part. In the Data Explorer part, we have two different options. So since we are selecting SQL API, so that's why it is displaying. So here, the common task is known as a new database. It is the no name of database. But in case of Cosmos DB, we can create two options. One is new container, another is a new database. So database, in case of database, is only create a database. But in case of container, it automatically create a database and then create a container within the database. So I first create a database, click on database, and here we need to give the database name, say DB, demo DB. One. And now we can provide the options, throughput options, that is there are two different options. One is auto scale, another is manual. Auto scale means as per your request or as per your load of the request, the throughput can be increased or decreased. Or manual means if sometimes a large number of users try to access our Cosmos DB account, in that case we need to increase auto scale throughput. But in case of manual, we need to go to this portal and then update the throughput manual. So I'll simply click on the our auto scale part and change the throughput to 1000. Sorry, auto scale, it is a default value 4000. So I'll click on the OK. So it will take some time to deploy this database in your database. Also, we can create, if we require, we can create a container also. So in case of container, we need to provide some extra feature. Like first one is a database ID or DB name. So container is basically means a collections or table. So whenever you want to create a container or collections container in a database, we first need to provide the database. Either we can use the existing database or we can create a new database. Say I'm using a new database. So DB2. Then throughput will be the remaining auto scale. And then here you need to provide the container ID or say table. Okay. So I'll provide this as an employee. And here I need to provide the custom ID or partition key. So I provide my ID will be my partition key. And then we need to either analytical storage or analytical storage required or not. That can be inside. Or if we require any unique key constant, that can be enough. So now we can click on the OK button. So it will create the database and it will take some fraction of seconds. So return back to the presentation. So if we want to perform a query, once the database part container is created, I'll demonstrate how we can insert a record. Meanwhile, I will discuss the query portion. So In database part, if you want to select the query and we are using the SQL-based API, then simply we can run these types of query in database part, like select from, select start from form, and then the container name or collection name. Also, you can perform the join to fetching the record because we are using the SQL type API. But if we are using the Mongo type API or other type of API, then this functionality will not. So to say, now there are two different databases. One is DemoDB2. If I expand this, there is no options or nothing details is available. But in case of DemoDB2, if I expand, then say there is another collection is called employee. Because when we create a second database, we're mentioning the collection name because we are in that time we are using the container. So now if we click on the employee part and click on items, then it will display us a blank part. So that because this employee info does not contains any information or data. Now, if I want to add new records, I need to click on the new items and then suppose I need to insert a record. This is my name record ID field. And now save the record. Click on the save. Save. In the below part, this content that successfully created the container. Now, if I go to refresh the records, there is a new record in appear. If I click on these records, so new record has been added here. ID, name, and this and PI. These are properties. So again, I am going to create another new record, and in that time, I am using the same structured record and using the another record ID. Also, with this record, I am providing some new field. Say account. In the previous record, I have only used a name property, and now in this record, I am using the two different new properties. One is name department and another is the designation. Now, if I click on the save button, so if I go in here, this record is inserted. Now, if I click on the new button again, then it takes it. So if I click on the save button, so again, the two records, but the two records structure is different. So first one is contain default four input values or auto-created value and the user defined value. But the second one contains four user defined value and rest are the system defined. So in this way, we can create a custom Cosmos DB data also. Suppose I have created another collection. One, two. use collect container. So please share the controller. And so let's see the upload options. So I have selected this. Okay. So if you want to upload a new record using JSON files, you can go to the JSON file. And if you have a JSON format data, and I'm selecting the student part. And if I click on the upload button, so it will create a 21 records. Right? And now, if we again go back to the Cosmos DB account and so these are the different records that has been already inserted in the Cosmos. And most of the data record has a parent-child relationship. So if we want to search any record, say new item, click on the new query part, and here this is a select start from P. C represents the first one default table. And if you run this execute selection part, it will return you the all records. So first two records we have inserted, and next are the data which are appeared or uploaded through the JSON file. So this is some examples of select query. Similarly, we can like this. We can also mention like select star from P. P represent the collect selected schema or collections. Also, we can select the specific field name or property name within the query, or we can use type Ds within the string conditions. So these are some example of the different types of Cosmos DB query. Also, in case of Cosmos DB, we can perform joining, like use a join clause, use a joining inside documents. We can join between documents are possible, cross joins only we can possible, and useful for projecting or flattering arrays for sub-documents. So this is an example of a joining clause. So in this way, we can perform the joining layer. Also, Cosmos will support different aggregate functions like count, sum, average, max, mean, etc. In case of Cosmos, we know group by clause is required. We need just only to implement this clause in the functions, value function, and simply call from the data. So this is a sample example of the aggregate functions Cosmos. Now the last topic is server-side object programming concept in Cosmos. So we can create server-side objects like stored procedure, trigger, or user-defined functions, where we can implement custom business logic or some custom some validations like inside data for Cosmos DB. Since, as I told earlier in this session, that Cosmos DB does not maintain any referential integrity. So if I have a two different collections of in Cosmos DB, one is employee and another is employee details. And employee contains the employee ID, and that particular employee ID also stored in the employee details. And now, if I want to block that, user cannot delete any employee ID related record from employee table if there is a record in employee table. In that case, in SQL database case, we are normally performing the referential integrity, primary key, foreign key reference. But in that case, if we require this type of relationship, either we need to implement that relationship through applications, because if the applications block that process, or we can implement server-side programming like store procedure or trigger against that particular collection, so that that data can be changed before deleting in record. It can need to be changed in child table, and then according to the response, it will perform either delete or not. So in case of Cosmos server, the server side of always we have a logic required, and also this code is always required in a JavaScript based programs functions. So these are some functionalities regarding user-defined functions. So we can perform different types of calculations using UTFs. And this UTF is always stored in the UTF namespace. In case of stored procedure, we have different types of groups, operate on groups of documents in a collections, or a stored procedure stored in a set of documents or records. Group several operations into a single logical operations like business logic, and trigger is all about a trigger to perform any data validations or data transformations at a time of insert, update, or delete. In Cosmos DB, we have a pre-trigger or post-trigger options. Pre-trigger can be acted before inserting the record, and post-trigger can be acted after inserting the records. And this all are the need to implement it through applications. We cannot directly implement it from the backend. That's why we are calling this server-side coding. That is, any server-side applications need to invoke those objects to execute from them. So benefits is provide the procedural logic, encapsulations of code or business logic, share the logic between the different clients or different databases, abstraction layer can be implemented, and also the security. So these are the major benefits of the Cosmos DB. So if I return back to the portal, since I have created collections, and if I expand this record, then here I can see that items of records which are available here. So these are the records, and also here there are different options like store procedure, user different functions, and trigger. So if we want to create store procedure, then we need to select store procedure, or we can click on these drop-down buttons and select the server-side options anywhere. So whatever any server-side options we create, see, this is always created just like a JavaScript function. So we need to implement some logics within these functions, so that that particular operations can be occurred when the store procedure or user-defined function is executed in Cosmos DB. And also the performance, obviously. The performance is one of the major part in case of Cosmos DB operations. And in Cosmos DB, these are the provides or follow the transactions based on asset guarantees, then atomicity, consistency, isolations, and durability. Stored procedure and trigger are executed on the primary replica, cannot replicate in the secondary replica, but user-defined functions can define on any replica. If we implement replica set or replications in Cosmos DB, then this concept disappears. And transactions is limited only for a single purpose, not for multiple purposes. So for creating the Cosmos DB applications, we can need to use JavaScript query API, which we have shown. And these are the quite fluent-based API. And most of the queries can be composed using either any of the API. So these are the steps for creating a store procedure. Like this is a sample example. So we can create a store procedure like this. So get contains the context of the database, and then fetch a response from the user, and we can set the response. So store procedure can be done or cannot be done from directly. No execute command is available in Cosmos DB. So we need to either execute from Data Explorer or for using a REST API.